Welcome to the EGB120 supplementary video question. Alright, so this question here asks us to analyze the ideal op-amp circuit shown in the figure and find an expression for the output voltage in terms of the voltages VA and VB, and find the resistance values as well. So let's remember our ideal op-amp rules. So Vn equals Vp and In equals Ip equals 0. So if we look at this formula here, Vn equals Vp, I know that this voltage here, which is Vn, is equal to this voltage here, which is Vp. So I'm going to just call Vn and Vp, we can just set them equal to each other, so I'm just going to call them Vp for this question here, just to make it easier. We're going to do Kirchhoff's current law at this Vp node as well on our non-inverting terminal first. So if we label currents coming off here, we might call this one I1, this one we could call I2, and the current coming back I3. So I1 plus I2 plus I3 is 0 according to Kirchhoff's current law. I1, so when we're working out these, we need to look at our starting voltage, which for all of these is going to be Vp. Subtract the voltage that we finish off at, so for this one would be Va, divided by the resistance of the branch that we're at, Ra, plus for I2, voltage that we start at, again is Vp, minus the voltage that we finish at, Vb, divided by the resistance Rb, plus, we know from our golden rule, In equals Ip equals 0, so this is actually going to be 0, so that goes to 0, so we can say Vp minus Va on Ra plus Vp minus Vb on Rb equals 0. So almost there, we just need to get a relationship between this Vp variable here and our output voltage. And we can do that by doing some analysis on this non-inverting terminal down here. So if we look, we can actually do a voltage divider here. So this voltage here is at this node here on top of R1. So I can say voltage here, which is Vn, which is equal to Vp, we know is a voltage divider, so we can say that it's the voltage Vo here spread out across R1 and R2, and the resistor that we're interested in is how much is across this R1 resistor here. So it's a voltage divider from this VO across these two R1 and R2 resistors here. What this means now is that you can actually flip this equation around and rearrange. So we could call this equation 2, and this one up here, which we made equation 1. So substituting expression 1 into expression 2 and just doing a little bit of rearranging and modification, we can actually get the final expression for V out. So it'll end up being with just a bit of algebra and shifting, R1 plus R2 all on R1 multiplied by VARB plus VBRA. So this is just using a common denominator here, all on top of RA plus RB.